Hello, and welcome to this introductory video on vectors. In this presentation, we will give you a brief review on vectors regarding their definition, some basic operations, and some applications. A vector is a quantity that has both magnitude and direction. It is typically represented by an arrow where the length represents the magnitude and the arrow points the direction of the vector. In this example, the tail A of the vector AB is the initial point, while the tip B is called the terminal point. Similar to real numbers, we can perform various operations with vectors such as addition, scalar multiplication, subtraction, and products. Vector is probably the most important and powerful geometry concept in the physical sciences and various engineering disciplines. You can use vectors and diverse operations to find the lengths, the angles, and the area of an arbitrary triangle in space. You can also derive some interesting formula such as the generalized Pythagorean theorem or the one for computing the length of the midline in terms of the size of the triangle. You can also use vectors to efficiently represent points, lines, and planes in 2D or 3D spaces, and to find relationships between these, such as distance between a point and a line, and distance between a point and a plane. In this video, we will review three basic vector operations: addition, scalar multiplication, and subtraction. Suppose we have two vectors, u and v. We can add these two vectors geometrically in two ways. The first way is through the Parallelogram Law. We first bring the two vectors together into one common initial point. Then we construct a parallelogram span by these two vectors, where the sides having magnitudes and direction corresponding to the two vectors as shown. The addition u plus v is the vector in the direction of the diagonal as shown. The second way is more straightforward. It is called the triangle law. Again, starting with the two mentioned vectors u and v, this time we bring the initial point of vector v to the terminal point of vector u. U plus v is the vector starting at initial point of u and ending at the terminal point of v. Remember that addition of two vectors always result in another vector. We can also scale a vector, making it bigger or smaller, by multiplying the vector with a real number. In vector operation context, such real scaling factors are called scalars. For example, if we have a vector u, we can make it twice bigger by multiplying it by the scalar 2, or we can make it twice smaller by multiplying it by the scalar 1/2. If the scaling factor is negative, the resulting vector will change to the opposite direction on the same line. For example, if we have vector u, negative of u is a vector with the same magnitude as u, but in the opposite direction. And another example is negative 2u is a vector opposite to u, but with twice the magnitude. Keep in mind that multiplying a vector with a scalar also results in a vector. To subtract two vectors, let's say we would like to find the difference u minus v, we treat this as the operation u plus the negative of v, and simply perform the regular vector addition. Also, a quick way is putting the initial points together. Then u minus v is the vector starting at the terminal point of v and ending at the terminal point of u. Again, similar to addition and scalar multiplication, the difference between two vectors is a vector. So, in this video, you have reviewed some facts about vectors. That is a very powerful and useful tool. You have also learned how to add two vectors by the triangle law and the parallelogram law. You have also seen that we can make the vector bigger or smaller by scaling it with a scalar multiplication. And lastly, we have also learned how to find difference between two vectors. In the subsequent sections, we will learn two products which will open doors for us to explore more application.